Now we'll try to derive the second normal equation of the OLS criterion. So to get the second normal equation, we are going to this was our OLS criterion. To get the second normal equation, I'm going to differentiate summation ui hat square with respect to the second estimator beta 2 hat. So again, summation ui square, when you differentiate it, you will get 2 times summation ui hat into differentiation with respect to beta 2 hat of summation ui hat, right? Okay, and that just went off the screen. One second. Right, ui hat. Now I'll just expand ui hat, so that will be, this is equal to 2 times summation ui hat into differentiation with respect to beta 2 hat. Instead of summation ui hat, I'm going to write yi minus beta 1 hat minus beta 2 hat xi, right? So that's 2 times summation ui hat into differentiation of yi with respect to beta 2 hat is 0. Again, beta 1 hat with respect to beta 2 hat, when you differentiate you get 0, and minus beta 2 hat xi is the only term with beta 2 in it. So when I differentiate this final term with respect to beta 2 hat, I am left with minus xi, which means my first order derivative is minus 2 times summation ui hat xi. The second step of the derivation, step 2, like I did earlier, is my first order criterion, right? So I have to set the first derivative equal to 0. First derivative with respect to beta 2 hat, which I found out is minus 2 times sigma ui hat xi is equal to 0. If I take minus 2 to the other side, it will become 0 divided by minus 2, so it will be equal to 0. That means I get summation ui hat xi equal to 0. Now I'm going to write the ui hat as yi minus beta 1 hat minus beta 2 hat xi into xi equal to 0. Once again, I'm skipping the screen. Now I can first multiply this and I will get summation yi xi minus beta 1 hat xi minus beta 2 hat xi square whole equal to 0. Right? So if I open the bracket, I have to take the summation sign inside. I will get that as summation yi xi minus, since beta 1 hat is a constant, I can write it as beta 1 hat summation xi minus, again beta 2 hat is a constant, so beta 2 hat summation xi square is equal to 0. Taking the last two terms to the right hand side, I can write this as summation yi xi is equal to beta 1 hat summation xi plus beta 2 hat summation xi square, and this is my second normal equation. So my first normal equation is summation yi is equal to beta 1 n times beta 1 plus beta 1 hat plus beta 2 hat summation xi, and my second normal equation is summation yi xi is equal to beta 1 hat summation xi plus beta 2 hat summation xi square. That's equation 1 and 2. Now from the first equation I can write beta 1 hat as equal to summation yi minus beta 2 hat times summation xi whole divided by n. Okay, now I'm going to put this relation 3, putting relation 3 in my equation 2, which is the second normal equation. So what I get is summation yi xi is equal to summation yi by n minus beta 2 hat summation xi by n times summation xi plus beta 2 hat summation xi square. When I expand the brackets, I will get summation yi xi is equal to summation yi into summation xi divided by n minus beta 2 hat times summation xi whole square divided by n plus beta 2 hat xi square. So I'm going to keep it like this, summation yi xi minus summation yi into summation xi by n is equal to beta 2 hat of summation xi square minus summation xi whole square by n. So beta 2 hat can be written as summation yi xi minus summation yi into summation xi divided by n whole divided by summation xi square minus summation xi the whole square by n. If I multiply n on both sides, basically to make it look pretty, I can write this as beta 2 hat is equal to n times summation yi xi minus summation yi into summation xi whole divided by n times summation xi square minus summation xi the whole square. This is one version of the formula of beta 2 hat. We can actually write this in a simpler method or a simpler manner in terms of deviations. The same formula as earlier can be written as beta 2 hat is equal to summation xi minus x bar into yi minus y bar divided by summation xi minus x bar squared. If we denote yi as yi minus y bar and xi as, observe that these letters are the small letters to denote deviations from the mean for each variable. I can write this in much simpler method, simpler notation as summation xi yi divided by summation xi squared. Now this formula is the same as this formula and the earlier formula that I showed.